Right. Mm. In today's program, I'm going to teach us the proof for the sum or difference rule of derivative. Okay, so the topic for today is sum or difference rule. Sum or difference rule of derivative, or simply differentiation. Okay, so our today's topic is sum or difference rule of derivative. So we are not going to use numbers here, but we shall prove that the derivative of sum of difference is the sum or difference of their individual derivatives. That is, let's say that suppose we have two functions that are differentiable, say y, or say y equal to f of x plus or minus f of x plus or minus g of x. Okay, where the two functions are differentiable, that is f of x and g of x are differentiable, that is, they are both differentiable functions. Okay, then the derivative of y, which is giving us dy dx, okay, giving us dy dx, okay, giving us the y dx is equal to f prime of x is equal to f prime of x, f prime of x, or plus or minus g prime of x plus or minus g prime of x. Okay, so alright, so I said, suppose we have a function given above which is y equals to f of x plus or minus g of x, where f of x is a differentiable function and also g of x is also what? A differentiable function. That is, where f of x and g of x are differentiable, then the derivative of y, or the first derivative of y with respect to x, okay, or simply say the y dx is equal to f prime of x plus or minus g prime of x. Okay, so we shall provide a proof for this. Okay, let's say proof. All right, so let us establish a function. Let us establish a function that is y equal to f of x plus or minus g of x. Okay, let's call this equation 1, our first equation. Okay, so our main aim is to derive this formula. Okay, our main aim is to derive this formula. So in this case, I shall do for that of sum after we shall do for the difference. Okay, so for the sum of the functions, for the sum of the functions, we have for the sum of the function, we have y equal to f of x plus g of x. F of x plus g of x. Okay. So let's call this equation A now. Equation A. Okay. So now we shall establish another function, or we shall simply say, in place of y, substitute. Okay, let's say in place of y, substitute or put y plus delta y, okay, from the left hand side of equation A. Also, in place of x, in the same equation A, we put x plus delta x. Okay, so doing that we have y plus delta y is equal to f of, in place of x now, I have x plus delta x, and again plus g of x plus delta x. Okay, so so what I actually did was, from our equation A, from the left hand side, I substituted in place of y plus delta y, and in place of x, for that of f of x, I put x plus delta x, plus in place of x, for that of g of x, I put x plus also delta x. Okay, let me say, anyway, no need to name the equation. All right, we go. Let us solve for delta y. We solve for what? Delta y. Okay, to have solving for delta y, we have to take y from the left hand side, okay, across the right hand side, such that the plus sign changes to what? Minus. That leaves us with this delta y equal to f of x plus delta x plus delta x, then plus g of x plus delta x, g of x plus delta x, then minus y. All right, so recall that y is given in our first equation as y equal to f of x, let's say y equal to f of x, okay, plus, since we are dealing with plus sign, plus g of x. So in place of y, we have to substitute f of x plus g of x. Okay, so I think at this point I will have to give this a name. let's call this equation A2, or let me say equation B. Okay, let's call this equation C. This is for easy reference. So I can say, recall that y is equals to f of x plus g of x. Okay, so I shall put, or let's say put f of x plus g of x into y in our equation C, in our equation C. Okay, that gives me delta y equals f of x plus delta x, f of x plus delta x, okay, plus g of x plus delta x, then minus f of x minus f of x, okay, let's reduce this for simplicity, minus f of x plus g of x. Okay, all right, let's call this our equation D. Okay, all right, we go again. We shall open the bracket. Okay, yes, at least we have a bracket here which can be opened with -1, okay, in equation D. So doing that, we have delta y equal to f of x, let's say delta y equal to f of x plus delta x, okay, plus g of x plus delta x, then minus, then the bracket opens now. Minus times plus f of x gives me minus f of x. Okay, minus times plus g of x gives me minus g of x. Okay, so minus g of x. So, yep, let's call this equation E. All right, okay. So, let us now rearrange the equation. This equation E, that is bringing minus f of x close to f of x plus delta x, and bringing minus g of x close to g of x plus what? Delta x. All right. We continue to have, okay, doing that we have delta y equal to f of x plus delta x plus delta x minus f of x. Okay, minus f of x, then plus g of x plus delta x, g of x plus delta x minus g of x minus g of x. Okay, So we have delta y equals to f of x plus delta x minus g of x. Okay? Plus g of x plus delta x minus, sorry please, delta y equals to f of x plus delta x minus f of x plus g of x plus delta x minus g of x. Okay, let's call this, sorry. Let's call this our equation G. Okay, now at this point, we divide by delta x, divide by delta x, meaning that we are dividing both sides by what? Delta x. That gives me delta y over delta x. That gives me delta y over delta x equal to f of x, equal to f of x, delta x. Okay, since delta x is our divisor, let's do that one first, then we go to the dividend. So we have f of x plus delta x. Note that this delta x can also be denoted with h. Okay, so f of x plus delta x minus f of x minus f of x plus g of x plus g of x plus delta x, g of x plus delta x, g of x plus delta x minus g of x. Okay. All right. Okay. All right. So we have to take the limit of, okay, now for simplicity, since by a simple glance on this we see that the space, okay, is our problem, so let us try to reduce this. Okay, let me do it individually. Okay, or simply let me say delta y over delta x, that is delta y over delta x equal to, now for that of f of x, let me have this. Okay, please, this is for simplicity so that we see what we are doing. Okay, so we now have f of x plus delta x minus f of x. Okay, so this one is the first one, delta y over delta x equals to f of x plus delta x minus f of x all over what? Delta x. Okay, so now if we take the limit of both sides of this equation, now let's call this equation a sub 1. We call it equation a sub 1. Okay, equation a sub 1. All right, let us take the limit of both sides now to have the lim of okay, delta y all over delta x. That is delta y all over delta x. Okay, as x approaches 0. Okay, as delta x tends towards 0. Okay, is equal to equal to, mind you, we're taking the limit of both sides, okay? Equal to this over delta x, that is f of x plus delta x, okay, minus f of x. All right. So we call that we are taking the limit of what? Both sides, okay? So limit of f of x plus delta x plus f of x all over what? Delta x, as delta x approaches what? 0. Delta x tends towards 0. Okay? That's, since given this the case, okay, that we have the limit of, we have the limit of what? Delta y over delta x, as delta x tends to 0, which is equal to limit of what? F of x plus delta x plus f of x, as what? Delta x tends to what? 0. Okay? This is the limit definition of what? Derivative. Okay? So far the limit exists. Therefore, lim f of, okay, let's say, so far this exists. We have, okay, we have, or, okay, you said lim f of x all over delta x. Okay, let me say lim delta y over delta x, as delta x approaches 0, is equal to dy dx. As delta x approaches 0, is equal to dy dx, or simply it equals to f prime of x. Okay. Okay, fine. Okay, yes. We mean that the limit of what? Delta y over delta x, as delta x tends to 0, is equal to what? Dy dx. Okay? Dy dx. Alright. So we have this to be what? Our dy dx. Dy dx. Okay? Again, we have limit of f of x, limit of f of x plus delta x plus delta x. Please wait. Lim of f of x, let's say, okay, all over delta x, lim of f of x, okay, x plus delta x, okay, minus f of x is equals to f prime of x. Okay, that is, as delta x tends to 0, as delta x approaches 0, is equal to f prime of x. It's equals to f prime of x. Now, wait, equals to f prime of x. Alright? So, okay, so we say again that lim f of x plus delta x minus f of x all over delta x is equal to f prime of x. Okay? So, but mind you, the way you pronounce it is limit of f of x plus delta x as minus f of x all over delta x as delta x tends to 0 is the same thing as what? F prime of x. Alright, we go to that of what? G of x, okay? So that lim of g of x, limit of g of x, okay, let's say as delta x, okay, all over delta x, sorry, all over delta x, okay, so that lim of what? G of x plus delta x minus g of x, okay, as delta x tends to 0, as delta x approaches what? 0, okay, is the same thing as g prime of x. Okay, so therefore we say that the y dx, which is limit of what? Delta y over delta x as delta x tends to 0, is our what? The y dx. Okay, we say that our the y dx is equal to f prime of x, f prime of what? X, okay, f prime of x plus g prime plus g prime of what? X plus g prime of x, okay, plus g prime of x. Alright, so what we have managed to achieve here is that given two functions which are differentiable, y equals to f of x plus or minus g of x. But in this case, we dealt with what? The positive sign, okay? Which is y equals to f of x plus g of x. That the y dx is equals to f prime of x plus g prime of x. Okay? Suppose that is the difference, we shall have f prime of x minus g prime of x. But in the next program, I shall provide the way we do when the sign is negative, but they are still the same way, nothing to add, nothing to remove. Thank you so much. Thank you so much. Thank you so much. Hope this helps. By Makasu Chinedu.